I think now it's
Yes,
visible.
sir. Now it is visible. Yeah.
Okay. So yes, in the last session we have already seen what are permissible stresses. So we have to understand what is permissible stress for concrete and the permissible stress for steel. The factor of safety for concrete is 3 and for steel it is 1.78. So now let us move to the next slide. So what are the various methods of design of RCC?
त्याला कसं समजणार की तू बसलेला आहेस ते अथर्व
Dear student, can you please
Students, please.
mute yourself? All students, can you please mute yourself? Please maintain the decorum of this platform. Okay, sir, you continue, sir.
Okay, sir. So now let us see what are the different methods of design of RCC. So the first is the working stress method, and the second method is ultimate load method, and then the final method is limit state method. So in this subject, we are basically dealing with the working stress method as well as limit state method. But we will see over the period of time, the first method which was developed was working stress method, and then after that it was ultimate load, and then finally limit state method. So let us see in detail what are these methods. So working stress method, it is a design method in which a structural element is so designed that the stresses due to working loads does not exceed the permissible stresses. These permissible stresses are nothing but the pre-assigned allowable stress, which is kept as some fraction of the ultimate stress. So I hope you understood the definition. It basically says that in this method, an element, a structural element, beam, column, anything is designed in such a way that the stresses due to the working loads, that the stresses which are developed due to the working loads does not exceed the permissible stresses. So basically we are comparing the stresses here. So when you apply load to a structure, stresses will develop, and those stresses should not exceed the permissible stresses. So permissible stresses, which we have already seen in the previous slide for concrete and for steel. Okay, so I hope this is clear now. What is the definition of working stress method? Now let us see what are the features of this method. So the first feature of this method is the actual stress distribution of concrete is not described. Okay, so it is assumed elastic, but concrete is not elastic. So we know that. So this method actually it assumes that the stress strain relationship between concrete is linear, which is actually not the case. So the actual stress distribution of concrete is not described. So we consider it as elastic. Okay, linear behavior we consider, but it is not a linear behavior. Now the second feature is same factor of safety is used for different types of loads. Now this is one of the drawbacks you can say of this method, that the factor of safety for load and for the strength, material strength, is not different as compared to the limit state method, where we can see that there are partial safety factors, one for the material and one for the loads. So in this, same factor of safety used for different types of loads. Now factor of safety does not predict the true margin of safety. For example, a stress factor of safety of 3 for concrete does not mean that the member will fail at a load 3 times the working load. So I hope you understood this point. What they're trying to say is the factor of safety does not predict the true margin of safety, which we are considering in working stress method. It is arbitrarily taken, it is approximately taken. So for example, a stress factor of safety of 3, which is considered for concrete, it does not mean that that member will fail at a load 3 times the working load. Okay, so that is the reason it does not give the true margin of safety. And the next point is it considers ultimate stress as the limit state of safety, but safety is a function of ultimate strain and not the ultimate stress. So as the name itself suggests that it's a working stress method, it deals with the stresses. So we have to basically compare the actual stresses with the permissible stresses, and then we design the member. So but what we have to understand is it considers the ultimate stress as the limit of safety, but safety is not a function of stress, it is a function of strain. So that is again one of the drawback of the working stress method. So these are the features. So in that you have to understand what are the merits and what are the demerits. So different questions might be asked. They can ask just write down the features, or they can say write down the merits or demerits. So you have to understand in these points what are the merits and what are the demerits. So the next point is the effect of creep and shrinkage is totally ignored. So this is one of the demerits, I would say, that the effect of creep and shrinkage is not considered in working stress method. Now the next point is it is a simple and reasonably reliable method. So basically it's a very simple and reasonably reliable method. So this you can consider it as a merit or advantage of this subject of this method. Okay, moving on to the next slide. The ultimate load method. So what do you?
Javed sir,
Yes,
Javed
sir.
sir, your video is off, no?
No, sir, it is on.
But why it is not visible here?
Wait, sir, just a second, I'll check.
Last time it was visible.
Just a second, sir.
Okay.
Okay, okay. Is it visible
Okay.
now?
Yes, yes, it is visible.
Okay, okay.
Okay, sir.
Okay.
Continue, sir. Sorry for interrupting.
And okay, okay, no problem, sir. And the screen is visible, the PPT.
Yes, yes, everything.
Okay. So coming on to the next method, which is ultimate load method. So in this method, the structural element is designed to withstand the ultimate load, which is obtained by increasing the working load by a load factor, giving desired margin of safety. So basically, ultimate load method, in this what we do, we use a factor of safety for the load to increase the working load by a load factor to give a margin of safety. So it's a very simple method in which we increase the load by a factor of safety and then we design the member. So now let us understand what are the merits of this method. So the merits of ultimate load method is while using WSM, while WSM uses only the linear part of the stress strain curve, ultimate load method uses fully the actual stress strain curve. So the working stress method, as I've said before, it only considers the linear part of the curve. But the ultimate load method, it also considers the actual stress strain curve, non-linear part also. So ULM uses fully the actual stress strain curve. The second merit is the load factor gives exact margin of safety against collapse. So the load factor which we are using in this method, it gives the exact margin of safety against collapse. Then the next merit is the method is based on the ultimate strain as the failure criteria. So as we have seen in the previous method that the stress was the main criteria, but in this method, the strain is the main failing criteria. So this you can consider as the merits of this method. Okay, so now let us see what are the demerits of ultimate load method. So it ensures safety at ultimate state, but disregards serviceability at the working load. So this is one of the major drawbacks of ultimate load method, and that is the reason we don't use this method. So basically, we are going to use only the working stress method and the limit state method. So this is just the introduction or the brief I'm talking about this ultimate load method. So it ensures safety at ultimate state. So it means that, so it is safe at the ultimate state, but it disregards serviceability. So what do you mean by serviceability? Serviceability, as I've already mentioned, deflection, cracking, vibration, these comes under serviceability. So what happens while you design the member with the help of ultimate load method, the section of the member is very thin. So because of that, what happens? There is a possibility of more deflection and cracks. So which, uh, because of that reason, the serviceability criteria is not met. So that is, it does not take into consideration the criteria of deflection and cracking. So in these members, you will see that deflection is more and also cracking is more. So that is one of the demerits. The second point is it does not take into account the effect of creep and shrinkage. So this is same as that of WSM. So again, in this method, creep and shrinkage are not considered. Okay. So now the third point is, since the method utilizes a large reserve strength in the plastic region, the resultant section is very thin. So as I just mentioned, that the resultant section is very thin because we consider the plastic region also of the curve. So this gives rise to excessive deformation and cracking. So since the section is very thin, ultimately it will deform more and cracks will also be more. So these are the demerits of ultimate load method. Okay, so I hope the ultimate load method is clear to you. Now coming on to the last method and the most important method which we are going to do in the entire syllabus is the limit state method. Okay, so let us understand what do you mean by limit state method. So in this method, a structure is designed for safety against collapse and checked for its serviceability at working loads. So basically what we are doing, whatever is the drawbacks of the working stress method and the ultimate load methods, everything we are trying to cover in this. And then we designed a method which is called as limit state method. Limit means the maximum capacity to which we can go. That is called as a limit. And the limit state method, in this both the factors are taken into consideration, that is the collapse, limit state of collapse, as well as limit state of serviceability. So limit state of collapse we check at ultimate load, and limit state of serviceability we check at working loads. So this is nothing but the limit state method. So let us see what are the features of this method. So it is a plastic design method. So basically I told you the first method, it only considers the linear part of the curve, but this method will consider the actual stress strain curve. That means it will consider the plastic region also, non-linear part also. Now the second feature is it gives comprehensive and rational solution to the design problem. So it gives comprehensive and rational solution to the design problem. So the most economical section is designed with the help of limit state method. And then we have, unlike WSM, which is based on calculation of working stress of material alone, and unlike ultimate load method, which is based on calculation of ultimate load condition alone. So this point comes actually in the definition of limit state. So whatever is the drawback of WSM, it is covered here. It is taken care of here. So now let us see what are the types of limit state. Okay, so limit state, there are two different types as I've already mentioned. It is divided into limit state of collapse, also called as failure, and second is limit state of serviceability. So limit state of collapse is further classified or divided into limit state of flexure, compression, shear, and torsion. So flexure is nothing but, flexure means bending. Okay, so beams we design for limit state of flexure. And what about compression? Column we design for limit state of compression. Shear, design of shear of the beams, we do it with the help of limit state of shear, and torsion, and so on. So I hope you understood what is limit state of collapse means. At the failure, what are the different methods by which a member can fail? It can fail either by flexure or compression or shear or torsion. So I hope this is clear. Limit state of collapse. Now the second part is limit state of serviceability. Serviceability means like throughout the service of the building, what things needs to be considered. Okay, so the most important thing is deflection. So deflection is something which is very important as far as serviceability is concerned. You don't like to see a member which is deflected because that gives a feeling of uneasy or a feeling of fear. Okay, so you don't want to see a beam which is deflected in a building. So we try to avoid that. And the next is cracking. Obviously, nobody wants to see cracks in the building. Obviously, that will result in fear. And third is vibration. So nobody likes the building to be vibrating with the slightest of the motions around. So these are the limit state of serviceability we have to take care of. So limit state method, it includes everything, limit state of collapse as well as serviceability, we check everything. So these are the types of limit states. Going to the next slide. So now we will compare what is working stress method and limit state method. So working stress method, it is based on linear stress strain relationship. As I've already mentioned, I think by this time you must have understood what are the various differences of working stress method and limit state method. So what you can do is you can just write in the chat box whatever so far you have understood the differences of working stress method and limit state method, and accordingly we will then go for the next slide. So whatever you understood, please write in the chat box whatever difference you understood so far. You have seen the features, you have seen the definition, you have seen the types. So can I have some answers from you? Yes, anyone? Any difference between working stress method and limit state method so far we have discussed? Okay, in working stress method, elastic portion of stress strain curve. We consider, okay, we consider elastic portion. Okay, understood. I hope that's what you're trying to say. Anything else? Anyone? So far, whatever you understood. Okay, limit state of collapse is more considering than serviceability. Okay, Mahfouz, WSM considers material stress only. That's correct. Good. Working stress is simple, reliable method. Correct, exactly. Very good. WSM gives thicker sections. Absolutely correct. So in WSM, what we get is we get heavier sections, and limit stress is plastic design method. Correct. So yeah, I think most of you understood what we have been doing. So that's good. In working stress method, the factor of sitting for load and material strength is same. Exactly. Very good. For us, Siddiqui, that is one of the difference. So it's good that you have been paying attention and you understood the difference. In LSM, we overcome drawbacks of WSM quite fair. WSM actual stress distribution of concrete is not described. Correct, absolutely correct. Okay, I hope all the students are not from diploma, whoever is answering the questions. Okay, in LSM we consider factored load, and in WSM we consider working load. Exactly, absolutely correct. So I hope the answers everybody gave, are they from a diploma or non-diploma? Okay, so I think you understood what we have been doing so far. So you can mention the difference between the working stress method and limit state method. So that's a very good response. So now let us move ahead and go to the next slide for the actual difference. So this is the comparison between working stress method and limit state method. So you can add if anything is missed over here, so we can discuss that. So the first is it is based on linear stress strain relationship, and limit state method, it takes into account the actual non-linear elastoplastic stress strain behavior of the concrete cells. So this is the basic difference. It considers only the linear part, it considers the actual stress strain curve. Now the second part, the stresses in the structural members are considered for normal working loads without considering the conditions existing at the time of failure. So the design is based on ultimate loads at failure. So this also we have discussed. Now the third difference is it does not give any idea about margin of safety available for loads to assess the extent of overloading without collapse. It gives an idea about the excess load which a structure can carry beyond the working load without collapse. So basically we are going into the plastic region also. So that's what they're trying to say. We can actually assess the structure can carry beyond the working load without collapse. Now the fourth point is material strength is not fully utilized in designing the member. So in working stress method, we get very thick sections, or we can say very huge sections. So material strength are fully utilized in designing the member. So that is one of the major advantage in limit state method. We get slender sections as compared to working stress method, and that adds to the economy of the structure. So economy is one of the major factors which plays an important role in designing the structure. So we go for limit state method since it is more economical as compared to working stress method. So now we have seen the difference. So you can add the differences which we have discussed. So now let us come to the next concept, that is concept of balanced under reinforced and over reinforced sections. Okay, I hope I'm audible. Okay, so now let us see what do you understand by a balanced section.
Yes, sir, you are audible, sir.
Okay, so thank you. Okay, so now let us understand what do you mean by a balanced section. So balanced section is the one in which the stresses in concrete and steel reach their permissible values at the same time. So I think this sentence is self-explanatory for everyone to understand. Very simple English, it is written that it means that a balanced section is the one in which the stresses in concrete. So basically we have two materials, concrete and steel. So the stresses in concrete and steel reach their permissible values at the same time. So that is called as the balanced section. Now let us see what is an under reinforced section. So an under reinforced section is the one in which the stresses in steel reach their permissible values first. I hope this is understood. In under reinforced section, what happens? Steel reaches its permissible values first as compared to concrete. Or you can also say that it is a section in which the percentage of steel provided is less than that of the balanced section. Okay, so I would suggest that you go with the first definition. That is, an under reinforced section is the one in which the stresses in steel reach their permissible values first. So we have seen the permissible values of concrete as well as steel. Suppose you have an M20 grade of concrete. So what do you mean by M in that and what do you mean by 20 in that? I hope everybody knows this. M refers to the mix and 20 refers to the characteristic compressive strength. I hope everybody knows that. And when I say it is an under reinforced section, so if I say the grade of concrete is M20, so what will be the permissible stress for that grade of concrete? Can anyone give me the answer right now? What will be the permissible stress for M20 grade of concrete for compression in bending? Since we have discussed the factor of safety and everything, I just want to see anyone. Just type in the chat box what is the permissible stress for M20 grade of concrete. Permissible stress in bending due to compression. 6.33. Anyone else? Any more answers? .45 FCK is not correct. My question is, what is the permissible value for concrete in bending compression for M20 grade of concrete? You're going into LSM Anis Patka. 6.67. That is absolutely correct. Rida. So the answer is 6.67. 20 by 3, absolutely correct. So now you understood what I was trying to say when I said that the factor of safety for concrete is 3. That means you have to divide the characteristic compressive strength by 3. That will give you the permissible value. So if you divide 20 by 3, you get the value as 6.67, or you can approximate that value to 7. Will also do, no problem. Okay, so I hope this thing is clear. So the permissible value for M20 grade of concrete is 20 divided by 3. So what you have to do, you just have to divide the grade of concrete with the factor of safety. So there is no need to remember the value of, it is called as sigma CBC. The value 6.67 which you got, it is called as sigma CBC, that is permissible stress in concrete in bending compression. I hope that is clear. Excuse me. Okay. So you don't need to remember all those values. What you can do is just remember the factor of safety and you can find out with the help of factor of safety. So we were at under reinforced section. Okay, so an under reinforced section is the one in which the stresses in steel reach their permissible values first. And now coming to the over reinforced section, an over reinforced section is the one in which the percentage of steel provided is more than that of a balanced section. Okay, so over reinforced section, or you can also say that in an over reinforced section, the stresses in concrete will reach their permissible values first. I hope this is understood. In over reinforced section, the permissible value of concrete will reach its permissible values first. So basically, whenever we design this, remember this very important thing. Whenever we design anything, we always design it as an under reinforced section. Okay, why? Because you want your steel to fail first. That is the reason you provide less steel, that is under reinforced section. And when the steel is less, it will reach its permissible values first. That is the reason it will fail first. And you know that when steel fails, it will give sufficient warning before failure. So that is the reason we always design any section as an under reinforced section. So please make a note of it if you want, or remember this thing, very important thing. We never go for an over reinforced section. The reason I just mentioned you, steel as a ductile material will give sufficient warning before failure, and hence we design any section as under reinforced section. I hope that is clear. And as far as balanced section is considered, it is very difficult to get a balanced section because we generally deal with a rectangular section. The beams which we deal is rectangular. So in a balanced section, there might be a possibility that you don't get the exact rectangular section. Irregular shapes of the section you can get. So that is the reason we don't go for a balanced section. So what is remaining is the under reinforced section. So that is the most important thing which you have to remember. The section, whatever we design, is an under reinforced section. Please make a note of that. Moving on to the next section. So now that is analysis and design of reinforced concrete beams. Okay, so we have covered the theory part of this. I hope everybody understood. And then at the end, we have to do the analysis and design of reinforced beams. So in this, we have different types: singly reinforced beam, doubly reinforced beam, singly or doubly reinforced flange beams. So what do you mean by singly reinforced beam? So any reinforced beam, any beam which is reinforced only in the tension side, only on one side, that is called as singly reinforced beam. If any section is, if the beam is reinforced in both the sides, that is tension side as well as compression side, then it is called as a doubly reinforced beam. And what are flanged beams? Flanged beam is nothing which are cast with in conjunction with the slab. That is called as a flanged beam. So in this module, we are going to see the design of singly reinforced beam, the design of doubly reinforced beam. So these two things which we are going to cover in this module, and that is given in the syllabus. So basically in working stress method, you are going to design beam and also you are going to design columns. And then after that, we are going to start with limit state method. In limit state method, you have beam, slab, column, and footing. I hope this is clear. Okay. So now let us go through the assumptions of the applications of elastic theory to the beam is based on the following assumptions. So these are the assumptions of working stress method. Remember, we are doing only the working stress method. First, we will start with working stress method, and after that, we will go for limit state method. So let us briefly discuss the assumptions. So even this might be asked in the exam. What are the assumptions of working stress method? So you should know these assumptions. The first assumption is sections that are plane before bending remain plane after bending at any cross section. So this assumption we have seen from a very long time in the previous semesters also. But one thing I would like to ask, what is the meaning of that? Can anyone write in the chat box and let me know? Sections that are plane before bending remain plane after bending at any cross section. Please write in the chat box what do you mean by this. The next assumption is all tensile stresses are taken by steel reinforcement and none by concrete. So what we are assuming is before going for the design of the beams, we have to understand what we are assuming. Assumption is the basic thing which we do in engineering. So we are assuming that tensile stresses are taken by only steel and it is not taken by concrete. And the third assumption is the stress strain relationship of steel and concrete under working load is a straight line. So this we have already discussed. We are considering it as linear. So that's what the assumption says. The stress strain relationship of steel and concrete is a straight line. That means it is linear. And the fourth assumption is the modular ratio M has the value 280 upon 3 sigma CBC. Okay. So in this we have a term called as modular ratio, which is given by the formula 280 upon 3 into sigma CBC. Sigma CBC is nothing which I have just mentioned. It is the permissible stress in concrete in bending. And the last assumption is there is a perfect adhesion between steel and concrete and no slip takes place between steel and concrete. So the last assumption is there is a perfect adhesion between steel and concrete and there is no slip between steel and concrete. So these are the assumptions of working stress method. Okay, I hope that is clear. So the question which I asked, sections that are plane before bending remain plane after bending at any cross section. One has answered strain is linear. Absolutely correct. So that is the correct answer. Sections that are plane before bending remains plane after bending means the strain profile is linear. Okay. So this might be asked in the competitive exams or anywhere. So you should know that the meaning of the first assumption is that the strain profile is linear. So now going to the next slide, singly reinforced beam. So I've just discussed what is singly reinforced beam. In singly reinforced, simply supported beam or slabs, reinforcing steel bars are placed near the bottom of the beam or slabs where they are most effective in resisting the tensile stresses. So we will see with the help of a diagram. Can you see the diagram? So this is a simply supported beam. So steel is required. Technically speaking, steel is required only where there is tension. Okay, so that is the technical definition of that. Steel is required only where there is tension. So we know that at the bottom there is tension for the beam. So hence steel reinforcement is provided. And you can see the cross section of the beam. So going on to the next slide, reinforcement in a cantilever beam. So the cantilever beam, we know that tension is at the top. So that is the reason steel is provided at the top. And you can see in the section, the two bars are at the top. And finally, the types of problems which we will see in singly reinforced beams are to find out the moment of resistance, to determine the stresses in the given section, and the design of the section. So these are the three types of the problems which we are going to cover in singly reinforced beams. Okay, so that was all about the introduction or the theory or the conceptual part of this session. So thank you for patiently listening, and I hope whatever we have discussed is clear to all of you. Over to you, More sir.
Sir,